This is question 18, the last question of the product and quotient rule assignment. Find f prime of x and find the values of x where f prime of x equals 0. So now we're not being asked to do a tangent line. We're being asked to find where the derivative equals 0, and that'll give us x coordinates where the function has horizontal tangents. So we've got a quotient function here, so I'm going to write out the quotient rule. U over v prime equals vu minus uv over v squared. We're going to make our table. U is x, so u prime is 1. V is x squared plus 225, so v prime is 2x. We'll now go get the derivative. So we'll have a denominator of x squared plus 225 squared. Then we're going to cross multiply this way. So that's just going to give us x squared plus 225, then minus x times 2x, which we probably could have done in our head. So that's x squared plus 225 minus 2x squared all over the denominator. So our final answer is going to be negative x squared plus 225 all over the denominator, x squared plus 225 all squared. So we'll go put that in, and we'll find out what the two places are where the derivative equals 0. So negative x squared plus 225, go down to the denominator, x squared plus 225, close the parentheses, square that. Well done. So now the only way for this fraction to equal 0 is for the numerator to equal 0. So all we have to do is take the numerator and set that equal to 0. So that's 225 equals x squared. Take the square root of both sides, but I need to put in a plus minus. So x equals plus or minus 15. And we can actually use the plus or minus symbol here, or we could have done negative 15 comma 15. We'll check that answer, and now I'll show you the workflow in the calculator. So I'll start a new problem, doc 412, a fraction x divided by x squared plus 225. So that is a pretty flat looking function, and we're going to open up the window a little bit. So I'm going to go negative 20 to 20 by 2's, and then I want to zoom way in, so I'm just going to go negative 1 to positive 1 by like fifths. Okay, so we get a little bit of curve there, so I'm going to tweak it just a little bit more, negative 30 to 30 by 5's, and let's go negative 0.4 to 0.4 by 0.1's. So that looks a little bit better. We're now going to go to a calculator page, take the derivative, x is our function, f1 of x is our expression, so they factored out a negative, so we can actually go menu 3, 1, take the whole thing, set it equal to 0, comma, solve for x, not y, negative 15 or 15. And then if we want to actually put in those tangent lines, I'm going to evaluate the function at negative 15. So that's negative 1 over 30. And then at positive 15, which is probably going to be positive 1 over 30. So we can go back here and tab. We'll put in negative 1 over 30. And then I want to do another red line, so I'm going to go 7 functions down. 1, 2, 3, 4, 5, 6, 7. And positive 1 over 30. So there are our 2 tangent lines that are horizontal. And that concludes this video.